Hello guys, welcome to my channel. We are doing second chapter of NCERT Physics class 12th, and this is the sixth video, sixth article, Acupotential Surface. So I'll explain to you Acupotential Surface. I'll read the NCERT line by line and explain it to you. So okay, so let's get started. An Acupotential surface is a surface with a constant value of potential at all points on the surface. As you can see from the term itself, Acu equal potential at all the points in the surface. It's exactly the Acupotential. Okay, our surface having equal potential all throughout its at all its point is called a Acupotential or the constant value of potential, or you can say there is no potential difference, and if there is no potential difference is zero, then the work done in moving a unit positive charge all throughout the surface will be zero. Okay, for a single charge q, the potential is given by, this is the how we give a potential for a point charge. Okay, and you see this is 1/4 pi epsilon naught q by r. So it depends on the charge and magnitude of the charge and the distance. Okay, so for a fixed distance, for a point charge at a fixed distance, the value of all the potential will be same. So for a point charge, this pairs that I draw around this will be the Acupotential surface. This shows that V is constant if R is constant. The Acupotential surfaces of a single point charge are concentric spherical surface centered at the charge. Like this, you can see for a point charge, the Acupotential surface are concentric spheres. Okay, now we'll move to the next point. Okay, and now the electric field lines for a point charge are radial lines starting from or ending at the charge. Okay, we know what is electric field lines are. They either start from like this for a point charge. For a positive, it will go away from the directed outwards from the point charge, or it can be inward if it is a negative charge. And so clearly the electric field lines at every point is normal to the Acupotential surface passing through that point. This is a very important part. You have to understand that electric field is always normal to Acupotential surface. Electric field is normal to Acupotential surface. How this is normal, we'll understand now. I'll read the paragraph, then I explain. This is true in general for any charge configuration. Acupotential surface through a point is normal to the electric field. Take any charge configuration. For that charge configuration, there is Acupotential surface. The Acupotential surface will be different. Okay, if you see this is a constant electric field, the Acupotential surface will be like this. This planes. Okay, these planes are Acupotential surfaces. For the point charge, we have seen concentric pairs. For two charges, for dipole, the Acupotential surface will be like this. These are all the points. They are all the region or the surfaces where the potential is same. For this charge is same. So whatever the configuration is, whatever the Acupotential surface configuration, the Acupotential surface obtained from the configuration, the electric field will always be normal. It will normal it everywhere. Okay, here you can see the electric field is normal to the surface. We can explain, we can have a proof for this. Okay, we'll see the proof now. If the field were not normal to the Acupotential surface, it would have non-zero component along the surface. To move a unit positive charge again the direction of component of the field, what would have to be done? Okay, suppose if there's this is not, you see here the electric field is normal to the surface. If it was not normal, then in that case what will happen? Suppose it is making certain angle with the normal vector. Okay, unit vector, area vector. Okay, then you can resolve this electric field in two components. It have a component horizontal. Okay, will have a horizontal component. Okay, to this Equipotential surface, and if this has a horizontal component, then what we have to do? We have to, if I'm moving a unit positive charge in this surface, Equipotential surface, against the electric field, I have to do work. This electric field, so I have to do work. And you know what's the definition of Acupotential surface? The potential should be same, and I don't have to do any work because the potential is zero. So this contradicts the statement that if the potential is same, I don't have to do work. Then how can I have to do work if in this case? So it cannot be zero. So our assumption is wrong, that it has a component on this. So it will always be normal to the surface. I hope this makes sense to you. So But this is a contradiction definition of equipotential surface. There is no potential difference between any 2 points on the surface and no work is required to move texture. This I have explained to you. The electric field must therefore be normal to the equipotential surface and at every point. Equipotential surface offer an alternative visual in picture of in addition to picture of electric lines around a charge. Okay, so we can visualize um, electric field. Apart from electric field, we can visualize charge and configuration with the help of equipotential surfaces. Okay, now for a uniform electric field, say along x-axis, the equipotential surfaces are normal to the x-axis, planes parallel to y-z plane. Okay, so you can see electric field which is parallel to x-axis. Then for this, the equipotential surface will be planes which are in y-z plane. Okay, plane parallel to y-z plane. Okay, equipotential surface dipole and identical positive are given here. For dipole, the equipotential surface are like this, and for a positive charges, these are given like this. Okay, I have made a, you can see this, I have made a video in fat simulation. Okay, so you can see that it is in Hindi, but you can, from that link you can see yourself how you can draw the equipotential surface in electrical, all those things in the fat simulation. It is very helpful to understand. Okay, okay, so this was the end of the video. Thanks for watching. And next video I'll try to explain the next topic. Okay, if you find any mistake in the explanation, please let me know, let others know. Okay, and thanks for watching.